everyone. My name is Manuel Deschamps. I work for Twitter, and I'm the tech lead for the mobile web team. And I'm here to talk a little bit about the architecture that we have built for our mobile web service. So first of all, we have to ask ourselves why we want to invest in mobile web. As we can see, the growth of the internet is shifting towards mobile. There are countries or generations that completely skip the PC area, and the first time in the internet is using a mobile device. So we need to make sure that we have a good experience and a good product for those users who, that's how they know the internet, through their mobile phones. As we can see, we're not talking about millions of devices anymore, we're talking about billions. So in order to reach pretty much everyone in the planet, we need to keep mobile in mind. So first of all, let's talk a little bit about what the implications of building mobile web applications are. For instance, one of the most important ones is the slow connections and the high latency. At Twitter, that's one of our biggest problems, that we still have most of our servers here in the US. That means that people who connect from Japan or Asia or Europe, they still have to come to the US and connect. So if they have this high latency, the service is not going to be very good, right? So we need to make sure that we optimize our client and our infrastructure in order to take care of these problems. Then we have the small storage and the slow CPUs. It's pretty obvious. We've seen, for instance, cases where browsers will only cache up to 20K, 30K. The rest of it is not going to be cached. So if you have these large assets, these large images, your users are going to be downloading it over and over. Plus, this added to the cost that most of the mobile devices pay per data. They don't have unlimited plans. This is going to backfire on you. The next point is that when we're designing new mobile applications, we need to think about the two sets of devices. Those are pointer-based and touch-based. So for instance, all the feature phones, they're mostly pointer. They use a cursor that you need a trackball or something to click on things, whereas the new ones like the iPod or Androids are touch devices. This is a huge difference, given that pointers, you can still rely on certain elements like tooltips or smaller targets. With touch, you have to make sure that in this very small screen, you have these big targets that the user can touch, and they understand what they are, and everything fits in the same screen. And the last one that we consider very highly is we have at least 10 plus major mobile browsers that comes from all the different vendors and different manufacturers that they ship their own browsers. That's very hard to build for or test, given that between different, you can have the same OS version and different vendors will have different implementations of the browser. So it has happened to us that we rely on certain technology like the SQL database, and a certain vendor will not implement it. So that means that you have the same user agent, you have the same OS, you have everything, but there's and then you get to this point where there's no database. So it's pretty hard. So when we started thinking about Twitter, a couple months ago, we decided that our strategy was that Twitter was going to be a mobile-first company. Mobile-first means that we're going to build and design our experience for mobile first, and then we're going to port them to desktop. That's the opposite of what we've been doing before, and most companies do that now, that they create this experience for desktop, and they just try to port it into mobile, making it look like a shrink version of the original. Mobile is part of the Twitter's DNA. The entire concept, the entire product was built for mobile. That's why we have this 140 character limit, and that's our plan moving forward. So if we want to reach everyone in the planet, we need to keep mobile in mind. And the other part of our strategy is that we want to have a consistent experience across all of our products, all of our platforms. That means that, and there's a difference between being consistent and being identical or a copy. If you have a product that you port from iOS to Android or Android to iOS, it's going to look bad. It's going to look like that you're just copying your designs and your product. What we want to do is that products need to feel native. They need to feel that they belong to that platform. But also a user can go from web to their Android to their iPad, and they don't have any problems using the product, right? Like they know how to use it. That's what we mean by being consistent, not just being identical. So for mobile web at Twitter, we have different products that define mobile in the company. We have the iOS apps, the Android apps, BlackBerry, Windows Phone, and we have mobile web. Inside mobile web, we run two products. One is our mobile web, kind of like for feature phones and older browsers. So this product was built using a lightweight mustache engine. So pretty much everything is built in the server. There's no required JavaScript. We add some JavaScript behaviors to make it nicer. Don't refresh the page that much. But I think like if you don't have any JavaScript and you're running at the lowest browser, you're going to have like, the page is going to be just like 7K. So we highly optimize it for places where data is slow, data is expensive. It's completely stateless. There's no notion of you are coming from this page, so I'm going to show you this. Everything, we keep it through the same, like it's just all server-side rendering. It also, like inside this cluster, we do the rest of the authentication, the rate limiting. It's really hard to detect spam coming from cellular networks, given that all come from the same IP. So we have to do other tweaks. We have a point-based system where we can do, like, based on certain actions and certain IPs, we know if someone is trying to spam, like create 1,000 accounts and follow people and things like that. And that's how we detect and rate limit some of these users. The mobile web cluster also provides the endpoints for the AJAX calls of the HTML5 client. So this is the second client that we have in mobile web. It's built on using HTML5, CSS3, and it's all client-side render. So this client actually implements some of the newest technologies that we have available in browsers, which is the application cache, that we use it so the user can run Twitter in their browser without having an internet connection. We use local storage to store all the data, all the like the tweets, the profiles that the user has been seeing. Also, if the user is tweeting and the network fails, we save it as a draft so the user doesn't lose those like 100 characters that he just typed. We rely heavily on 3D transforms and transitions to do like some of these like rich animations in the browser. Geolocation, well, we want to tag our tweets to know where the user is at. I'm just going to go really quick through what our product is, and then I'll dive more into like our architecture. The mobile, we defined inside the like our entire strategy. We needed to define what mobile web was, right? Like, why do we have an HTML5 client built in our browser when we have such good applications as the iOS and Android clients, right? So we were like, okay, our first pillar is that we want to reach everyone in the planet. That's one of the core values of Twitter. Twitter has 10 values, and some of them apply to the business, some of them apply to the company, to the employees, and some of them apply to our product. So we think this one is super important to us. The idea is that if you have any device with a browser, you should be able to get to us, and you should be able to use Twitter. Our second pillar is that how do we create a low friction experience for mobile users? The apps are great. They're super engaging. That's where we have our most valuable users, but also they have certain friction on the moment that you have to download it. You have to sign up for an app store if you don't have it. Like certain app stores require credit cards. So it starts to add friction to users to be able to use Twitter. So that's where we like the part that we want to tackle, be good at. And the third pillar is innovation through experimentation. That's another core value of Twitter. And what we want to accomplish there is that we want to being able to play with stuff, add new features, but adding it to the clients is really expensive, to the native clients, given that it's code that it ships and you cannot roll it back. A little bit of how this maps into our product. So reach every person on the planet goes through mobile web, the feature phone version. Like I said, it's all built with HTML4, no CSS3, and JavaScript is not required. Mobile Web Touch is the HTML5 client, and it's built with HTML5, CSS, Ajax, line-side render, iOS, Android, you name it. So when I talk about low friction experience, it's like it means everyone who comes from a URL, right? Like they're using their browser to search for something on Google, or they're in a Yahoo or in any page. They see a hashtag, they see a URL or an ad name, and they come to Twitter, to mobile web. So we want to provide a good experience so they can learn how to use a product, they don't feel lost. The logout experience is super important. Most of our users in mobile web are logged out. So it's really important that we provide the same level of experience and the same quality for the login users as the logout. In native apps, most of them are logged in. So it's a different set of problems because logged-in users, they can already tweet and fave, whereas logout, you have to tell them what the product is for. They mentioned it first. For most people, it's the first experience ever on Twitter, so we need to make sure that it's super user-friendly. We have a transition that goes from SMS, where it's like we have most people who had never had internet before, and they use SMS. And this is the first time they actually are using a mobile browser. So we try to transition users from an SMS client or an SMS experience to mobile web, taking them to the mobile apps. So this is one of the biggest challenges for the next years. How we're going to make sure that our users start using more of our web products or native products. Zero rate. Zero rate is very important for mobile web applications. Zero rate means that you deal with the carrier, so they are not going to charge for data. It's a good way to grow your product, and what you do is that you have to, like, the carrier has to whitelist or approve certain URLs, and you have to tweak your experience to tell the user, okay, you can use all these features, you can check their tweets, you can tweet, and if they're going to open a link, you have to tell them, after this point, you're on your own, you have to pay. But it's great. In countries like India, Turkey, we've seen tremendous growth through these zero rate programs. And these are really hard to do in the native applications, so this is where mobile web really excels at. I'm open this one real quick because they're super related. Innovation through experimentation is really important that you have your CI tools set up. We developed these release processes with other themes on how we're going to take code. Now that the entire company is mobile first, it's no longer the mobile team responsibility to build every feature that the company wants to make. So now we have, for instance, like the team, like the revenue teams, the search teams, everyone wants to build features, and they have to build them for mobile first. So we created processes, and someone called Release Shepherd is someone who's assigned every day to do the release for the mobile web team. So we use Garrett. It's a very good tool to handle the code reviews, and then it merges your code in your repository we run like CIs on every in every step, like in your change, in your integration branch, in your in like once everything is integrated, and in the release branch. We also do cherry picking, so we like to have full control of everything that we have in our repository from every other team, how we're going to pick certain changes, and those are the ones that get deployed. Rollbacks, we normally don't do any rollbacks. What we try to do is roll forward. So there is a release job responsibility to know if there is something bad with the current release. We do it in small stages during like an hour. So if the first stage something is going bad, he has to call the engineers who work on that feature and have it fixed and then roll it forward, like meaning push a patch right away. And prototyping on web is so much simpler than native. Native code, you're talking about that someone might download that client and never update it for the next 2 years. So if you added some code there that rely on some like test the experimental API and then you take it down, that client is going to crash. So now, a little bit of the architecture that we have built for mobile web in our HTML5 client. The core of the application, the lowest level that we built, we call the application core. It's where the most of the magic happens, and that's where we have things like, for instance, like our navigation controller. Now, it used to be more a hybrid. It used to use HTML5, push states, and hash bangs whenever we didn't have push state. Now it's pretty much just push state. Like hash bang is pretty much being removed from our mobile web client. But still, the navigation controller is the guy in charge of, okay, this view wants to open another view. I'm gonna change the URL, apply check the cache, see what view is coming next, and load it if it hasn't been loaded, things like that. Also, we didn't use any tool available like jQuery or Mustache. We pretty much rebuilt everything. We didn't build it just because we wanted to build more code. It was because we didn't find a tool or a library that met our requirements and also was small enough that we didn't have to download the entire kitchen sink. If you look at our namespace in like the browser debugger, you will see that we only have one object with 2 APIs. We try to encapsulate everything inside the application core. The application core is very tight and sealed, so there's no easy way to just start executing actions that you don't want, right? We've seen other behaviors in other websites or in our own websites where we make a lot of our functionality public through JavaScript, and people just do like these crazy things. They add like, I don't know, Chrome extensions that call and start like causing a lot of bad behaviors. We literally just have these two, which is like add a new component and use one or more components. And I'll explain you how this works. If you see how we add a component, in this case we're like creating the navigation controller. We define the name of it, and then we also have a dependency list at the bottom. This means that this component needs to have the history API in order to load. If you see, it's wrapped on this sandbox, so it's the application core will not call this function until it has all the requirements that it needs. So that allows us, for instance, to load things on demand if we want, and they won't be executed until we need them. In this case, for instance, the app navigation will not even be executed or called until someone else needs it, right? In this case, for instance, the application controller will be that I need the navigation controller, and then this call is going to be executed, and so on. Our sandbox, this T object that we call, is our sandbox, and is the only way that you can communicate with the application. And I'll dig more about our API in a minute. Then the next layer of our architecture is the application cache. This one is an event dispatcher. It takes events from views, from widgets, from modules, and dispatches it to everyone that is subscribed to those events. It's very like a DOM model. It's just with like fake events, not real DOM events. It's the one that allows views and other components to navigate through the application. Like, we never changed the URL by hand, given that we wanted to have this encapsulation of, okay, when are you using hatchbang? When are you using push state? Are you allowed? Is that view loaded? Like, there's a lot of conditions that are going on in going from the timeline to a tweet. So we need to make sure that we encapsulate all this logic in a certain place. And this guy is a guy who talks to the navigation controller and other places. How does it look? Well, for instance, like if you were defining a view, this is how you do it. Like you would say, well, I need to use the application API, and the T object, your sandbox, will contain like this and a ton more of functionality. But those are the main ones. Basically, you want to navigate. You want to ask for a widget. You want to ask for a data service. Like if you need to write to the database, if you need to call, like do an XHR call or anything, you have to do it through a data service. Views normally don't do any of these things. Like they pretty much just do UI rendering. And we got to the last layer of our architecture. This is where we have views. Views contain a header, a body. Like I mentioned it, our views are completely event-oriented, meaning that views never talk to each other directly. So I'll explain with some examples of how we accomplish that. We did that so we don't have these like tight relationships between views. So if you're in a tweet and you need to modify behavior or an element in another view, you shouldn't do it directly, because if that view hasn't been loaded, then you're going to have like errors there. They rely heavily on data services to do all the like local storage manipulation, all the AJAX. The most important thing that they do is that they manage their own cache, meaning that if you like, you can have a view that gets loaded with different parameters, like different tweets, different UI handles. So these views should be able to say, oh, I haven't loaded this tweet. I need to refresh my element and, for instance, show the spinner while the data is being loaded. Or I have loaded the data and just show it right away, make it as quick as possible. The other notion, like these things have been added over time. We added the notion of modules. Modules are just like self-contained blocks of functionality that we wanted to reuse in different views. So because widgets, a widget can be, for instance, a text box or a search box, right? It's just an element that has, that you just reuse that functionality in other places. But a module is more than that. For instance, if you want to have a small list of tweets that has just 3 tweets, and you click on them and they send you to the tweet details view, all these like aggregation of other widgets, we wanted to put them together, so we call that a module. And a module is literally just like aggregation of a couple, like one or more widgets, and then we reuse them in different views. And views have, other than just defining where the modules should be or should go, the views don't talk to the modules at all. The modules are pretty much self-contained. So I want to talk a little bit about the tight coupling that I mentioned. If we have this example, right? Like, let's say that you're in the timeline and you click on the tweet in your timeline and you want to open the tweet details view with it. If you do this, it's like a very tight coupling, right? What happens is the view hasn't been loaded. What happens if the there is the tweet is not valid or something? You're making the timeline responsible of the actions of the tweet details, and that's not very good. In the this is another example. This is more like visible of what can happen. If you're favoring a tweet in the tweet details, so you open the tweet, you click favorite, and now you want that that tiny mark in the timeline shows up when we call it the dog ear to show. If you do it that way, what if you landed directly in the tweet and the timeline hasn't even loaded, or that tweet doesn't even exist in the timeline? So you're just wasting time doing all these checks, right? So normally we just avoid all that. So here's how we solve these problems, right? In this case, we do it through the application API. So you clicked on the link, on a tweet in your timeline, and the timeline, the only thing it will do is just like open this URL with the status URL, and that's everything it does. The details view is gonna be initialized, and then it's gonna say like, oh, I got a tweet here, I'm just gonna render. And then both views did their job, and they didn't have to talk directly to themselves. So this means like there's no coupling. In this other example is more interesting. When you favorite a tweet, what we do is that we just fire an event, meaning that, okay, I have favored this tweet, and that's it. I've done my job, right? So this guy will just mark the red star, and that will be it. The timeline view on the other side is gonna, like, if it has been loaded, it's gonna subscribe to these events. So it's gonna be listening for when the other views fire the favorite event, and then it's just gonna add the dog ear to the element. No coupling here. Like, there's no way that if no one is listening to the event, nothing is gonna happen. So once we put all these architecture together, we come up with this. The communication is completely vertical between the views and the application. There's no communication between views directly. Everything goes through the API, through events, that way. Same thing with services. Manage all the data, all the I/O, things like even autocomplete, things like they have like this data logic. We do it through these services. So once we put all these together, what we come up with is that we can have like a mobile client and a tablet client using the exact same code. We just adapt the CSS. We might even tweak a little bit the HTML, but normally the entire JavaScript, the entire stack of the application is exactly the same between our iPhone and our iPad client. So as here you can see, the blue bar on top is the header, and the rest is the body. So we start digging into the view. You see more what I was talking about, like a module is just like that part that renders those tweets. So we can use that module, and it's called the tweets module. We put it in the timeline and say like, well, instead of 3, show 20 tweets. And that's everything we do. We reuse pretty much every single component we have. The one at the bottom is just a widget. Widgets is a lot more simpler. In this case, it's just like a rail of photos. And that's how we've been building our product for the last 2 years. Performance. Performance is one of the most important parts of our application and our development cycle. If you look at our payload, you will notice 2 things. One is that we inline most of our assets. The ones that we inline are those like our core assets, meaning like the framework and the 3 main views, which is the home, the tweet, and the profile. Those are our like 90% of the page views. The rest of them come in a deferred mode, and through a CDN or like just like a regular script call, completely asynchronous. It's really important to mention that deferred is not the same as on demand. On demand is not a very good strategy in mobile, given that you have this high latency. So imagine if you click compose and you had to wait, I don't know, 5 seconds for all the code to download. It would not be a very nice experience. So what we do is that once after the app loads, we start loading all these assets, and we just keep them in the backlog. Like, they are not executed. They're parsed, but they're not executed, and we just they're ready for whenever we need to use any of those views. Then they get executed and parsed. This approach helped us a lot in countries where they had very high speeds, but also very high latency. Japan and South Korea are very good example of those. Their cellular networks are really fast, but because they have to come to the US to fetch the data, the latency is pretty bad. So we try to optimize it as much as possible. And the technologies that we have used to improve our performance is the application cache. I recommend that you use it. The problem is that it's not developer friendly. It's really hard to work around all these issues. You need to use 404s to dump the cache. It's really hard. It's really hard to move users from one version to the other. So we came up with mechanisms where if there is a security fix that we need everyone to move to, we have to do these AJAX calls that force, say, 404 on the manifest and then refresh the page. So it's not a very good experience, so we only use it like once or twice a year just in case there is a security problem. Also, the application cache is not aware of any session. So if you embed any data in your HTML or in your, on your JavaScript about the user, that means that if the user logs out and then someone else logs in with the same browser, he is going to get that same data. So you need to be careful with that. That's how we use local storage. And local storage is pretty much just, for us, is like a giant set of sandboxes. So every user gets its own it's just key values. So every key is one user, and inside of it we serialize all the data. It's not perfect. Having to serialize the data back and forth is super costly. So what we do is that you can run a lot of write operations, and then after a couple seconds, we serialize it and push it. So the services are not aware of that. That's handled very low level. But we try to not to have to write to local storage for every single change. Because imagine you download 20 tweets and you have to update the timestamps of every one of them. You will be doing 20 plus write calls to the local storage. IndexedDB, no, we are not using IndexedDB yet. None of the major mobile browsers have implemented IndexedDB. So right now, yeah, I'm hoping one day. And web workers, we play with them a little bit last year and some other this year. And we found out, I did some latency and performance tests and noticed that the communication between the window and the workers is really slow. They literally just serialize everything back and forth. So if you, we haven't found a good case to use them in Twitter yet. We thought that we might do all the rendering in the main thread and then pass the tweets and all the objects to the worker and have the worker deal with all the storage and all the I/O. But it was slower than just do it in the main thread, just because all these serialization of elements going back and forth. And so, yeah, but those two combined, application cache and local storage, are super powerful. They cut down our times by 60%. We used to use SQL database with the local storage, but the SQL database has this huge penalty when you open it. So we were blocking the users about 2-3 seconds every time they loaded the page, just opening the database. So having to wait that long for that, it was not an option. I know about other strategies where people use local storage as their immediate cache, and then they start moving things to SQL as the local storage starts to get full. But because tweets are so small, we can store hundreds of tweets in your local storage before we hit the limits. But if you need to store big amounts of data, you will probably have to use a combination of the both. And yeah. So I think that's it. Thank you very much. If you have any questions, please shoot down.